together. So, so due to some internet problem, my guest he will share the screen with you. So, Ikoli, will you like to share the screen?
Okay, 1 minute. Uh,
Mhm. I will demo screen.
okay. Can everyone
Okay,
see the screen?
everyone can.
Yes, we can.
Okay, great.
Okay, so today I will teach you about today's our last and final, I think, last session of this Ecolab training for this month. And after that, you will be rewarded a certificate after a proper evaluation. And today I will talk about drinking water qualities guidelines and standards of WHO and countries. So let's move to slide number 2. Introduction. So, as if we generally talk about water is really important for us, not for in general, like every country has its own standard, and we mostly know about the WHO, means the World Health Organization, which controls the water quality level globally. So with this increased rate of death around the world, we know like the WHO decided to look for possible solution to have like prevent the pollution and protect the water sources all around the globe and to prevent the clean and safe water. Mean like that is good for quality standard characteristic which consume which cannot cause any significant health effect in human. So today we will talk about this units and convergence system because like the how the WHO reported the values which is really important for us to we should know. So we will talk about the unit convergence system and how we report the water quality parameter to general public like the people they mostly don't understand like what is this parameter is and how they are calculated. So we want to give you the knowledge about that and also how to, we can calculate like suppose suppose in second slide like physical and chemical microbial content, and now we are in third slide. We will show you about like the result, like what is concentration and unit. So the result from the laboratory basically they are reported in concentration to ease understand and analysis. What does it mean? Concentration mean like the amount of component or chemical per volume of liquid stated in unit. Like suppose if you took 1 liter of water from the market, so there is specified content of chemical is written on the composition, like how much it contain oxygen, what is the pH, and what is the suppose total hardness, what are the chlorides, phosphates. So the composition is written in suppose milligram per liter and microgram per liter. So these are basically the concentration in units. So the units basically mean the measurement which we use to know the quantity of substance, like how much any substance and any chemical is present in any water sample. Without units, it is unknown to us like what kind of chemical is present, like the chemical composition and how much it is present. So for any drinking water, even for industrial water, it is really important for us to, we must know about the concentration and the amount of the substances that is present in the water. So we have like suppose if we generally I talk about the simple example like CFU per ml, tell us the number of bacteria and volume of sample. CFU means like the colony of a bacteria. So further we have like several measurement physical units like biological and chemical substances like NTU, milligram, liter, ml, ppm, ppv. It is mostly written on the description of any water drinking water bottle. We will let you know about like how it is calculated and why it is very important for us. And every country has its specified units and specified conversion rate. Commonly they are exchangeable to each other. So we will focus basically on ppm to ppv and milligram to liter and microgram to per liter. Slide number 3, please. Yes, so here if you look at about like the conversion units, if you look at suppose ppm sometime written or milligram per liter is written, it means the same thing. Sometimes the people report the data in ppm or milligram per liter or ppv or microgram per liter, and 1 ppm is generally equal to like 1 milligram per liter. So it's the same thing is written to like 1 ppb is equal to 1 microgram per liter. These values are really important and is generally reported on any water sample. Slide number 4, please. Uh, uh, Concentration in unit. If we look at about the general example like ppm and ppb, here the two pictures showing like here we have suppose 200 liter barrel of water which will contain approximately ink concentration of 1 ppm, which represent concentration of 1 ppm. While if we look at about in the second slide, if we one drop of ink we can drop in the largest tanker truck, it will be like show us the concentration 1 ppb, mean like the largest strength. So these are the concentration which we use and how we calculate this. This is the simple representation which is really important to know how it is. Slide number 5, please. How to convert to ppb, and if any value is reported in ppb, how you will convert it to ppm, or any value if is reported to milligram per liter, and how you will convert it to microgram per liter. This is a very simple conversion unit which we must know to be familiar with this value. Like to convert ppb to ppm, you must need to divide simply the value by 1000. The same for the microgram per liter, you have to do like divide the value by again 1000. For the rest, have the same procedure. And the unit conversion chart, if we look at here, 1 ppm is basically equal to 1 milligram per liter, and 1 ppb is also equal to 1 microgram per liter. These are the specified value, like how it is calculated and how you will do the conversion. If any value is suppose reported 1 milligram per liter, it means that is 1 ppm. If it is 1 ppm, it means like it is 1 milligram per liter. This is a simple conversion unit which we have to understand about this. Next slide, please. If we talk about the guidelines versus standard, so WHO basically define the safe drinking water is that like does not represent any risk to health or the lifetime consumption, including different sensitivity that may occur between the life stages. Mean we have two things. One is the standard value, which is recommended by the WHO, which is mandatory, and one is the guidelines from the WHO also. But here we have two categories, guideline, one from the country and one standard from the WHO. Like every country has its own standard value, and also they are following the guideline from the WHO, which is recommended. So the WHO guideline for drinking water quality, it was initially reported in 2006, and guideline value to ensure the safety of drinking water. It is globally reported for every developed and non-developing countries. So standard vary among countries and region. I will show you later on, like suppose we will compare some countries' value regarding like suppose my country, Pakistan, and suppose Nigeria and some other countries. Slide number 7. So here we must know we have some parameters, and the first one is like physical parameter. Physical parameter is basically which we can predict physically, mean with the help of naked eyes, like the physical parameter of drinking water that are usually we can measure with our naked eye, which we can predict suppose the color, and physically we can test odor and temperature and turbidity. In general, we judge drinking water to have a good physical quality. It is clear, taste, and have no smell, and is cool. But the guideline for this value has not been established, such as like color. There is no guideline for color and odor and temperature globally, which have no direct link. Like there is no direct or adverse effect on the health. So there is no strict recommendation for the physical appearance. But the WHO basically recommend to us like the turbidity should not exceed in 1 NTU, which is like the unit. Its explanation is available. So, and perfectly much lower to ensure the proper disinfection. So turbidity can be noticed by physically mean by the naked eye, approximately about 4 NTU. It was reported by WHO in 2011. but some country has different value, which we will show you at the end of the PDF file. Next slide. Chemical parameter are very strictly recommended, and they have a strict rules, not only globally, which is recommended like according to the guideline of WHO, but also strictly recommended by the each country. So these are the largest group of parameter in the regulation, and must be specific substances like such as individual metal, organic compound, to generic substances such as pesticide and the disinfection by product. Drinking water like pose concern like health related problem. If we expose to these kind of impurities, we will be exposed to adverse side effects. So diseases may occur to chronic, and also, if you look at about there are a few chemicals, suppose basically lead, which can help the problem of the short-term exposure, such as nitrate, and there is a massive contamination of drinking supply. So it is possible to test the water for all the chemicals that could cause a health problem, and nor it is necessary. So mostly chemical rarely occur when result from human contamination of small area affecting only a few water resources. So we will mainly focus on chemical parameter, which is strictly recommended, and all the adverse health effect is associated with the chemical parameter, not the physical parameter. Slide number 9. So let's talk about, we have several important chemical in the water, which is really important. We must know about the concentration and what is the recommended WHO guidelines. Suppose if we talk about arsenic, and practical difficulties in testing and removing arsenic is like hard. But the WHO suggests to us like the drinking water should have less than 10 microgram per liter of arsenic. Is the same mean like if we do the conversion unit from microgram to milligram, it's mean like 0.01 milligram per liter of 0.01 ppm or 10 ppb per liter. And also they reported like this is the general example to give you like what is the WHO standard and like how we should know about this, and we will compare this data with the each country standard. So if we talk about chlorine, it should not be exceeded like 5 milligram per liter. So if we exceed the threshold, like the order of the threshold, like 2011, it was reported in 2011, most of the people are able to test smell and chlorine drinking by concentration below 5 milligram. In some level, it's like 0.3 milligram per liter. Same is the rules for the fluoride, like WHO recommend drinking water should not exceed 1.5 milligram per liter of fluoride. And in conversion unit, it is like 1.5 milligram per liter or 1.5 ppm. Same for the iron, there is no suggested guideline. Like there are some recommendation like which is recommended by WHO, and some are recommended by the country. In this case, the WHO does not have suggested any guideline for the iron in drinking water. So because why it is not reported? Because it does not have like adverse side effects on the health. The next slide. Nitrates and nitrite, like mostly these came from the agriculture sites. So the WHO basically suggests to us like it must be like nitrate and nitrite must be less than 50 milligram per liter of nitrate and 3 milligram of liter of nitrite to protect against methylomegalovinemia in a bottle, pit, and pan, means short-term exposure. It is really important. Nitrates are they have severe side effects on the health, and the ratio of the concentration of each guideline should not exceed 1. It means like per liter. So if here physically, in general, if we talk about like a drinking sample water contain 30 milligram of nitrate and 155 milligram liter of nitrite. So does this sound like how we will calculate the ratio of concentration that exceeds the guideline value? So it's really simple. Just divide the 30 milligram liter of nitrate divide by this is basically nitrite. So 50 milligram of nitrite. So you will get the like the water sample in the WHO guideline. You will get the value from here, and the same on the other side. The sample 1.5 milligram and divide by 3 milligram. So you have to add these both the ratio, and the value is 1.1. It means like if your value exceeded 1, so it means like the drinking water, it does not follow the WHO guideline. So regarding the same case for pH, the pH is globally a standard one, which is recommended from 6.5 to 8. But in some countries, it is reported as 8.5. It varies between the country and region. But commonly, the WHO recommend the pH of any drinking water should be in the range of 6.5 to 8. But there is no strict restriction on this. But and also the pH is important operational water quality parameter according to the WHO agreement of 2011. Next slide, please. Same is the case for the sodium. Again, it's like a potable water, and typically it must be less than 20 milligram per liter. So they cannot exceed. They can greatly exceed while in some countries. So no WHO guideline is also established for sodium because sodium has also no severe like health side effects, negative side effects. So however, like generally the sodium in excess of 20 milligram per liter give rise of unacceptable tests like the salt will be, the water will be like too much salty, but it's general. Globally, there is no strict restriction on sodium concentration. If we talk about the calcium, also for calcium, there is no strict established guideline, but they have some problems like regarding if the value exceeds from the 500 milligram per liter, the people will not be able to drink that water because of the quality like calcium and magnesium, because of the drinking of the test, because bicarbonate have a test. So bicarbonate, like suppose they have also no human health effect, but most of them, or some of them, is like acidic and basic. But we should also not exceed the concentration level of 500 milligram per liter. Regarding lead, which is really important for as WHO recommends, so we should not exceed the lead concentration 10 microgram per liter because it causes severe health diseases like neurological or cardiovascular problem in future. And vinyl chloride, regarding vinyl chloride has been should not exceed 0.3 microgram per liter. So we should memorize and look this value, which is recommended by the WHO, but this value may vary between the countries because of the climate change and because of the environment. Regarding the copper, if we talk about, so the guidelines say to us the concentration should pound and should be less than 2 milligram per liter. Next slide, please. To talk about the microbial parameter, regarding the microbial parameter, it consists of a group of pathogens, like suppose ranging from smallest viruses, including bacteria, protozoa, and helminths, like fungus is also included in this one. But the WHO guideline for drinking water quality basically recommends that all water that is for drinking should have zero facial contamination in 100 ml of sample, because they pose severe health problem in human through waterborne transmission, which vary in severity of like gastroenteritis to severe, sometimes fatal diarrhea, dysentery, hepatitis, and typhoid fever. Like the primary basic recommended E. coli is of paramount importance because of microbial quality drinking. So it has been used for many years, indicator of contamination by fecal matter. The E. coli is specifically detected and treated or distributed water. There is a potential risk to human health, like mostly it causes diarrhea and have severe health diseases. But the WHO recognized that zero fecal contamination can be difficult to achieve. Why? Because of developing country where many people really household and small drinking water system. It is recommended that in these settings, the WHO guidelines should be seen as a global for the future rather than an immediate requirement. So we should be also focusing, and it is really important, the microbial contamination and the chemical contamination. So we should follow the strict rules for the microbial parameter and as well as for the chemical parameter. Next slide, please. Okay, so this was about general introduction, just to show with you the slides. It was showing like what are the physical parameter, chemical parameter, microbial parameter, and which of them are really important. So the chemical parameter we should consider strictly a microbial parameter because they have severe side effects on health. But the physical parameter is not really strict for us. And also the chemical parameter we showed you in the slide, which is recommended by the WHO. But as I told you, the WHO rules may vary for the region. Like suppose it may be different for Asian countries, may be different for suppose African country, for the Middle East, and suppose for the other Western side. So we will talk about, and we will just now show you some data of the standard of any countries. Like suppose from Pakistan data, I will show you. Can you share the PDF file on screen?
Okay, so we're about to share the standard for different countries. We just actually discussed about the WHO guidelines for drinking water quality. So now we'll look at this different types of standards, like Mr. Amir Hassan, he has just said. So now I'm going to put up the screen to be able to display this. Just give me 1 minute. So we want to look at first, I think we'll talk about that of the UK, then we United Kingdom, and you see what we mean by country standards, not guidelines. So I think I'm going to share now. So 1 minute. Okay, so great. So this is a document for that of the standard for UK. So Mr. Amir, over to you.
Okay. Can you move a little bit up so they will see it from the top? Yeah, water quality parameter. Actually, if you look at it, can you open the in comparison with the Pakistan? So we will move.
Okay, so this is that of Pakistan.
Yeah, this is the government of
So
like
national standard for
ministry.
drinking water quality in Pakistan. I want to do a comparison with that of United Kingdom. So I think I'm going to go straight. Okay, I think.
Yeah, this is okay. And also with Nigeria, I took Nigeria as example. It will be like African country.
Nigeria is here. Okay, so let's look at it like this.
Okay, so if we talk about the standard recommended data, and let's talk about from the Pakistan, so it will be more easy for them.
So these are for physical. So we start first with bacteria, and let's see.
Okay. So this is the standard or any country is different. Like suppose from my country, Pakistan, we have a Ministry of Environment, which is responsible for these kind of activities to like they can issue, like not normally and normal people can afford this kind of data. We work with the WHO and UNICEF to issue this proposal, like to make it standard for our country. So what is here, if we look at the parameter, like properties are parameter, bacterial. First, if we compare the bacteria, like all water intended for drinking, like suppose E. coli or coliform bacteria in Pakistan standard, like what is the Pakistani standard value? It must not detectable in any 100 ml sample. And WHO also recommend the same thing, like it must not be recommended, like detectable in any 100 ml sample. And most of the Asian country in remarks follow the WHO standard for this bacteria and for this sample. So this is the comparisons. Now it will be changed. If we, in some rules, it will be changed. Now, if we look at a little bit down, again, treated water E. coli, like if the water is treated, again, they said to us the WHO and Pakistan standard, like the sample, 100 ml, it must not be detected. And most of the Asian country, we follow the same procedure with the WHO. So go down, so it's the same thing, like it's very clearly written. Yeah, we have the same rule again in this case, like treated water and distribution system, like E. coli or thermotolerant coliform, total coliform bacteria. In 100 ml of sample, it must not be predicted. It is in Pakistan recommended, and also it is recommended by the WHO, and we follow the standard rule of the WHO in this case. Like if we talk about in case of life supply, it must be like 95% of the sample taken throughout, like within 12 months of period, we have to take the water sample and test it. So here we follow the standard procedure. Now, if we go down and the values may be changed, let's move down. Okay, in this case, it's the same thing. May I just go down so we will compare very specific values. Yes, maybe here. Okay, yeah, yes, okay. If we talk about chemical, like essential inorganic chemical, in this case, if we look at about aluminium, in Pakistan, the standard value must be less than 0.2, but the WHO recommend if it is equal to 0.2, it's like acceptable. And regarding anti-money, it's clearly written in Pakistan, we recommend like the standard value, the P mean like Pakistan standard value, it must be approximately less than 0.05, and the WHO recommends 0.02. The same like for the arsenic, we recommend like the value must be less than 0.05 milligram per liter, mean the value must be less than 0.05 per liter, while the WHO recommend 0.01. It means we written it is the standard for Pakistan and most Asian developing country. So here it is to show you like the WHO rule is recommended to us, but it may vary between the country and between the region. So here we can clearly see, we have shown you, like in my country, we in some cases we follow the WHO guideline, but in some cases it is standard for my country. Below, if we look at about the cadmium, here, like in boron, we are following the same procedure. Barium, we are following the same standard of the WHO. But in regarding cadmium, we have 0.01 is recommended, but the WHO recommends 0.03. So it is the standard value for Pakistan. Again, chloride, we recommend less than 250, but the WHO recommend like almost equal to 250 is acceptable. Again, the chromium is almost the same. Copper, we follow the same procedure. Let's move down. Yes, cyanide. Regarding cyanide, here is clearly shown. It is the standard for us.
I say fluoride as well. It's less than or equals to.
Fluoride. Yeah, regarding if we look at about the lead, so the lead is like must be approximately less than 0.05, but the WHO recommends 0.01. So it means this value is also standard for Pakistan and most Asian countries. So this is just the comparison which clearly we showed you, like we have government rules like this value for any drinking water sample should not exceed, and how the WHO is not to propose it must not be the same for each and every country, and some value must be the same, some standard value we will follow and some we will not follow. If we now we look at about Nigerian standard, let's see. Yes, here if we compare about organic constituent aluminum like milligram per liter, here the maximum permitted level in Nigeria is 0.2, and arsenic is 0.01. Like here it is also written, it's like what are the health impacts, but the value is quite different if we compare with the Pakistani standard and then with the, like suppose aluminium. If we talk about the aluminium,
let's try to pick up maybe one or two of these parameters. Let me say fluoride and chloride, and let's see what happens. So yeah, I think in fluoride we have 1.5. That is the standard for Pakistan, and then let me check that of Nigeria with C fluoride. This is it. It's 1.5. So Pakistan, it's saying less than or equals to 1.5. So it's almost similar. But if we are going to check, let's say lead, less than or equals to 0.05. And let's check for Nigeria. You see, it's different. 0.01.
Yes.
So
So
this
this is the
is
comparison
mhm.
data for each country, which we can clearly see it may vary between the region. Like in the Asian country, we follow the different values and procedure, but in African, it is you can see it's clear, totally different. But it is according to the WHO standard.
So
Mhm.
this is that for the United Kingdom. So if
Yes.
we go down, you're gonna see similar thing. Let's just check
Yeah.
for two.
If you look at about you can, if you go a little bit up, there is a
Uh-huh.
pH about which we talk about pH.
Uh-huh.
Yes.
Yes.
Yeah. Here, if you see here, it is written 6.5 to 9.5, but the WHO recommended pH is 6.5 to 8.5, which is in general, it is 6.5. If
Let's
we
check.
compare
Let's
the
check it.
pH,
Yeah, I think. Let them see under pH. Uh,
it was,
okay, this
pH,
is it. This is
yeah, it is
WHO.
6.5 to 8.5, but for the UK, it is recommended 9.5.
Hmm.
Yes, it's clearly written like the pH in this region is quite different. So it is the standard for the region, like for the western side is 6.5 to 9.5. But for the physical parameter, generally we don't have any strict rule. Like we talk about the color or turbidity, it's very quite similar. We can just
Okay, so I don't know. Isami Hassan, are you still there?
yeah. So generally, we almost share the basic information to the student was the general information to share like how the WHO guideline is and how the standard for each and every country is. So I would like if the student has any kind of question regarding the data comparison, how they can collect and how they can combine, we will try to answer. And if they need any kind of help or information, so I would like to listen you.
Mhm.
Thank you for your kind attention again.
Is there any question? If you have some worries,
Yes.
okay.
Yeah. Good evening. Thank you very much for your presentation, Mr. Amil.
Yeah.
I just wanted to ask something about the references. I saw the reference is a little bit old, and normally they recommend we use the latest because I saw you are using WHO 2011.
Yeah.
So, because we're a little bit moving, they normally recommend we use the latest references, for example, 2020 to 2021, 22. So can you please maybe help us, at least we get also those updated
Mm-hmm.
guidelines? Can
Mm-hmm.
you just give us a
Okay.
through light?
Okay, I thank you for your question. I know, but there are some rules which we did not have. Like suppose if we talk about the pH the recommended is like the same as it from the beginning, which was proposed the WHO. So in some rule, it does not change. It became the same for many years, and it will be the same forever. It cannot be changed. But regarding the data, it's updated. Like we just want to share with you the basic information which was proposed by the WHO. It may change as why then we compare the data between the countries with you, like suppose, okay, Pakistan, Nigeria, and UK.
Okay,
So this
so
was just a comparison to show you like how we do and how the data varied between the regions.
Okay,
yeah.
thank you, Mr. Amil.
Thank you. Yeah.
So I think
You-
it's a really good question. Normally, I want to say that, as Mr. Sanov rightly said, there's a document I'm trying to check for and to show you. So this is a whole document that was written, like he said, some long time ago in the 1990s, around this period. And this document for WHO's guidelines has been written, and it's just like a guide. It's like a workbook. So every other
Yes.
analysis or every other thing you're doing, you look it as if it's like your workbook. So every country comes to this workbook or this textbook, I can say, and look at the values and then try to look at their environment and try to look at their hygiene and sanitation behavior, and to look at their water resources, how they are connected. And then from there, they can be able to think through with some kind of also scientific approach by testing the different water sources for drinking. And then they can be able to fit up to see how they can measure with that of the guidelines which have been proposed by WHO. And I have this document. After the question from John, I think I'm going to share a document so you see this document. It's not been changed. Okay, Mr. John.
Yes.
Mhm.
Yes, thank you, Mr. Sterling and Mr. Hassan for presentation. I wanted to understand what are the differences, what factors do countries use to set their standards? Because we see there is a difference between the standards and the guidelines from WHO.
Okay, thank
So what are the factors that are used in setting this according to
okay.
different countries?
Thank you for your question, John. Actually, as I told you, like in my Pakistani database, it was comparison. Like we have a different region in the world, like suppose Asian region, African region, Western side. So Asian side, the environment is different. Basically, the water composition also varied with the, suppose the Middle East, they have a different water composition because of the environment. The Asians have a different because of the environment, because of the mineral resources that is present inside the earth. So they are mainly basically responsible. So the water may deviate, mean they may be differentiate from the African side, from the Middle East, from the Western side, and from the Asian side. So it depends on the region, the composition of the mineral and resources that are present inside in the environment. Can you hear me, John?
Yes, I get you.
Okay, so I just want to give 1 minute for all those who are still. Yeah, I think Collins, your hand is still up.
Yeah, let's hear first. Okay, Colin, do you have question?
Thank you very much. This one is maybe just to highlight more. I saw in the entire scope of the training, we were concentrating more so much on these heavy metals, but it's like we have left out some part, the emerging contaminants. For example, the pesticides, the pharmaceuticals, those are things we have neglected a lot, and they are causing a lot of issues. I happen to be working on a research where we are trying to develop a material that can be able to remove pharmaceuticals, because these drugs normally are persistent in water, especially in wastewater, and at least in Uganda, we have researchers who have found out that these have penetrated even through these state-of-the-art wastewater treatment plants. So I think maybe you can throw a light on the emerging contaminants, because I saw in the presentation we have not talked about them, but they are
actually it was just for the basic, like there was maybe we don't know about the level of the student like who join our training session, but there was a big presentation with me, but regarding discussion with the colleague. So because of time limitation, we cannot share, but I know I have full presentation regarding how we do the pesticide and what are the level of that pesticide and what are the procedure to how we can predict it. So next time, if we have a time, then
maybe you can share a little light on that. Maybe just throw a light since the question.
Yeah, let me find on screen and then I will share with you. Let's see.
Okay. So while Mr. Hassan is looking for that, I'm going to share the WHO guidelines, which is the 4th edition, which is the one which is the recent and common. If you search online, you're gonna find it. I'm gonna share. Now, I think everyone can see my screen. Probably. So this is the whole parameters or contaminants which are possibly with the guidelines. You see the table of contents. It's a whole everything that concerns contaminants in water. So we have here, this is the first substat. So this is the guidelines for drinking water quality, 4th edition. Just search online. You'll be able to see this. It's the latest available. This is 2011. So that's why most references are being cited in 2011. It's the most recent, like Collins asked before. So you see, 2011. This is the cited references. So I don't think the last time I checked, it was still this year. We had a training on water quality technician, and still the same. I downloaded this, and it's still the same. So that's it. Mr. Hassan, you got.
Yeah, I found. Just want to move to that slide. Yes. Show it here. The exact one, which.
You can share because I think I.
Yeah. Yes. Okay, let me share my screen. You can allow me. You see my screen? Can you
Yeah,
see
I
my
think
screen?
it's coming up a little bit. Yes, okay. Yeah, we can see.
Okay, so we have various slides, like how we do the calculation methodology, I suppose. And there's a material and method, like how we do the various parameters we should check it, and what are the like dissolved oxygen. We have the method about dissolved oxygen. What are the methodology? What is the procedure? How we do the calculation, and regarding the interfaces, biological oxygen, mnemonics, methodology, determination of load, dissolved oxygen. Very big presentation, but bacteriological analysis, we have like how we can calculate the bacteria by various methods, membrane color, how we identify the color, measurement, spectroscopic methods, we have like how we do conductance, total dissolved oxygen, and pH. And here we have nitrate, like sources fertilizer and manure decay vegetable, like how it's came from in nitrogen fixation by bacteria. How we do the calculation, like presence in natural water, chloride, sewage, method of nitrate estimation, which came from mostly nitrate came, as I told you in my presentation, from the agriculture resources like fertilizer, pesticides. They mostly contain nitrate and nitrites, and how we do the calculation. So these are the interfaces, procedure. Like nitrate, we mostly do by the electrode method. Phenolic, the disulfonic acid method, we can calculate and try to evaluate the nitrate and fluoride. Okay, sulfate, ammonia is also basically came from most of the resources from the pesticide, because that are fitted to the agriculture. Method of ammonia estimation, we have the methods like how to calculate the method for ammonia estimation. Metric method, phosphates, these are also present in agriculture. Phosphate, phosphorus estimation, stannous chloride, So in general, if we talk about, it's a very big presentation, but I have everything which was not possible to cover in a small presentation. But if you need, I will try to share with you later on.
So
Who was this question?
yeah, Collins. Yeah.
Yeah, Colin. Yes, yes.
Mr. Amil,
Yes, yes.
yeah, before maybe you close, can you throw more light on that device, the ICP? We happen to have one in Uganda. They have just brought it, but unfortunately, we haven't understood it. So, can it also be able to detect these emerging contaminants? However much in literature they say it is good for detecting heavy metals. Can it also help us? Because currently we don't have the liquid chromatography, but we thought that machine can help us detect these pharmaceuticals in water.
But if you don't have the column chromatography, you have a titration technique. If you know, if you have a laboratory technician, you can ask him about titration technique. You can do it by titration.
Okay.
Because I don't know now about which device you have exactly, like what's the number and specification. But mostly, if you don't have a column, you can do by titration method, which is possible.
Okay, I think I will maybe get maybe offline and you send me some of those things, because we have the inductively coupled plasma mass spectrophotometer.
Okay, you can
That
write
one
me
in your
full,
last slide.
okay, you can write me your full text message about your device and what you want to exactly carry it out. So then I will try to answer you.
Okay.
Mhm.
Okay, thank you.
Okay, I think if there's no other question, I think we're done for today. And every other information about the certificate, please send in the group. The group will be open, up for chat from today, and questions can be asked about certificates or fieldwork generally, and how evaluation will be done. So we're going to try to talk about that in the WhatsApp chat. If there's no other thing, I think that's it for today. Thank you, Mr. Hassan, for the excellent presentation. And thank you everyone that
Thank you
made
for
it to this last day of the training. Okay.
Thank you to everyone. Thank you for
Yeah.
listening. Thank you for your kind attention.
Okay. Bye-bye.
Thank you. Bye.
Thank you. Goodbye.